Hello everybody, welcome back to From Rhythm to Algorithm Part 14, Evolution and Technology. This episode, this will probably be a pretty long one, is a direct response to Lex Friedman if he could ask an alien some questions. I would also like to ask an alien some questions, but I might have some decent thoughts that might help somebody out there. Actually, the introduction's a couple more thoughts on P versus NP. Because let's be very specific. Like I said, the last video, that's for me as a mathematician, that was the money shot for P versus NP. But let's be very specific about what we've solved. I showed why P cannot equal NP from a direct physical result as a statement of an equation. But saying P does not equal NP is a different logical statement than P versus NP. Versus is a word to dichotomy. What's the difference between, again, I don't even remember what the sets were. You have a problem, okay, so a couple of the thoughts that I wanted for P versus NP, you have, basically they're asking is, if you are given a solution, or if you can quickly verify that a solution is correct, can you find a solution? Assuming a solution exists is where it gets really, like I said, that's the assumption that just makes it a wonky problem for me. But do solutions exist? Well, in chemistry class, a solution is a mixture. Language is a mixture. A solution in mathematics is an adequate response to, again, why the problem emerges. And all mathematical problems are faulty linguistic assumptions. But is there problems? Do solutions exist for all problems? No. When you have a game, like the word game, Sudoku, basketball, there's not an algorithm to win basketball, but when you set rules, that is where an algorithm comes into play. But that's, like I said, the last video was the actual proof. But it's a great introduction to biology, and to talk about the large-scale evolutionary trends of different alien civilizations. So we've talked about and introduced an axiom called infinite uniqueness. Speciality, we've talked about it logically, but it's why everything differentiates, why there's different types of life on our planet. So then that's why I have existence of solution, chemistry, biology, the size of sets. Like I said, numerically, P does not equal NP because there's every set of anything or any category is infinitely unique. Nothing is exactly equivalent. Like in linguistics, everything's proportional or everything is, correlated. It's drawing equality signs, and we'll do another math video, but we'll stick to biology, and then for the technology section, we're going to specifically talk about how do we move faster. But locality and concentration, the getting away from P versus NP, just look at the different types of biological life we have on our planet, and at the different rate of evolution they've gone, right? A blue whale is the largest animal we've ever had on our species, or on our planet. But the size of sets for biology. Life tends to go down in size. Let's say, all right, we eat cows, we eat pigs, we eat chickens. It's because there's been larger size counterparts to most animals we've seen, but they were just hunted and eaten at the beginning. So there's not a lot of uniqueness to metabolism for large-scale biological evolution. Like I said, anatomy will be very structurally similar. Metabolism will be very structurally similar. We'll have DNA for sure. They'll have eyes. Will those eyes be trained to our visible light spectrum or to some other spectrum? Definitely will vary, but the difference is wearing glasses, literally. Advanced general intelligence does not exist. I also have up here super intelligence. Let's just consider three civilizations. One 50,000 years ahead of us, one 50 million years ahead of us, and one 5 billion years ahead of us. I don't think I really, from a biological perspective, I don't think there's going to be much differences at all. Biology and anatomy, they'll have structure, they will have shape, they will metabolize energy from the environment. It'll vary tremendously, but again, if you have to metabolize, I don't know, let's say they eat silicone and lead, it's still a body processing a chemical. So that will all be extremely similar for every development of civilization. How about sexuality? What do I think? I think all, let's try to make it some, so I don't know, right, what's the difference between a human being and a tree? Is there some difference? Probably. Are they both life? Yes. Sentience is the ability to feel. Autonomy is the ability to move. Do trees move? They don't move around on the planet, but they distribute energy or the nutrients in their body or in their trunk. They can move their arms. So we'll get to the technology, but what is movement? What is not movement? Work requires movement. So I'm sure there won't be any plateau. Although every sentient life form will be sexually reproductive. Emotional progression. I think I do have some good insights here. Death, mortality, and African tribes. They will view any civilization, I think our civilization, there'll be technological plateaus, but there won't be biological plateaus. It's always just about experiencing, and right, the environment's always changing, there's always new people living and dying. So they'll be stronger individuals, and they will be stronger group thinkers. Not group think in our way, but special cohesion. And so, like I said, think about the animals on our planet. Does a goose know how to fly in a V pattern with other geese? Yes. Does a goose squawk at you if you kick it individually? Yes. So is it an individual? Yes. Is it a part of a group? Yes. Are we individuals? Yes. Are we part of a group? Yes. And so both of those will strengthen together. But the overall sentiment of any species, really, even our own, I think is very close. Do they mourn death? Are they sad about people that die? Yes. Are they that sad? No. Are we that sad? No. So life is when shit matters. But they'll definitely, the sentiment of their species will be more playful. It'll be much more childlike. And not in an exaggerated way. Literally every biological organism is aware to some extent that they can die. So it's just acceptance of the reality which makes you have playful and curiosity. And it's when you grow up and have to pay your bills and try to find a mate that you get all bitter and cunty. And so once you have technological plateaus in your society, the sentiment of the society will be much more playful, it'll be much more fun. I used to have a saying called fear is for the living, but fear is for nobody. Fear and regret and literally any negative emotion does not actually exist. It's just at the species level, when you're in an emotional race to the bottom, you're literally transferring hatred, you're literally transferring fear, you're literally transferring insecurity with your words. But that will truly just go away, and I don't think our species is far from that. Like, how do we look at death, right? People, the ones that pass before us, walk with us every single day. Yeah, I totally agree. There's no closed systems. So what if it's exactly what it is when people on their deathbed or near the end say they see people? Well, what if we talked about heaven and hell as analogies, and they are, and language is bounded by the living, but what if that shit's just kind of fucking real? And like, you die, and it's basically like your life was you're a video game, your life is your saved data, and the environment's the environment you were just in, with all of the other saved data entities and creatures that existed before. It'd be like the best video game ever. But the point is, there are no closed systems. And so I have up here African tribes. A lot of African tribes, when someone's sick, they will sing around, they will dance and sing around the person. I also am very confident that it has above zero scientific value, but not substantial scientific value. So I just wanted to point that out. But like I said, the sentiment of the species will be a lot more playful, will be a lot more juvenile. Besides the person of their species that derived a lot of science, they won't be that intelligent. So there's no super intelligence in that sense. I'm not super intelligent. I can derive mathematics for 10 straight years and write one more axiom. And so also for the P versus NP, right, like how many axioms exist? Infinite. It's just, again, what fundamental relations can you draw about the world around you? So even in a biological sense, P versus NP, the sets with solutions is infinitely smaller than the statements of sets without solutions, but all solutions are related to the "it is what it is" statement. Let me make sure my camera's still going. So what I was saying is, it was all solutions would relate to the "it is what it is" statement. But the biological reason of infinite uniqueness is why nothing is exactly equivalent. No person's exactly the same. We all have 5 fingers. Well, most of us have 5 fingers, but nobody has the exact same, like, actual mass and shape of fingers. So that's why the biological, physics, but life is the solution of physics. The universe wants to be more efficient. Well, you can evolve organisms with choice. And so that's the biological motivation for sets not being equivalent and the identity, right? I is me, I am the only me, you are the only you. That's, you can even cast this in a biological way, and it makes a lot of sense. A couple more questions for biology, then we will move on to technology. Said superintelligence does not exist. Oldest species in transpermia. Was there a conscious? Was there a first initiation of life somewhere? Probably. Is there any species or civilization that is aware of that? No. Again, I don't know. I would firmly conjecture no. And like I said, superintelligence doesn't exist. You have 1 or 2 people that kind of derive everything, and past that, I said there's a plateau to what intelligence is. I said I can talk to literally anybody, and if they are honest and open with me, I will learn something from them immediately that I genuinely didn't know. But like the oldest species in transpermia, like, would human beings say, let's go colonize Mars? At the beginning of sentient life, past microbes and plant life, to, again, sentience making choices, not sure the difference between plants and animals. It wouldn't have been conscious. They wouldn't have made a definitive choice. We are going to send our, I don't think so, send our, again, they would have to spend living individuals to go colonize something. I genuinely think it would be like, DNA from a plant comes from one planet and just floats over to the next. So by the time you have actual sentient species, nobody knows where the beginning was, and there's no way to find the answer. But was there an actual beginning? Yes, biologically. And same with Lex says, why did the universe start? The universe, okay, I can't answer why did the universe start, but I can answer why did R1 become R2. And that's because of imbalance. Past that, again, instability, somehow we can make a physical argument about what knowing is. An electron knows it's an electron if it repulses another electron. An electron doesn't know, knows it's dealing with a not electron if it attracts it. But why did the universe start? Why did vibration start occurring? Well, why do stability points change? Why do phase changes of the universe occur? Why did we go from vibration to light to matter? It's instability. It's some geometric reason that I don't know. But that's what I got there. And now we'll talk about technology. So now let's talk about technology. First, let's do a simple demonstration. I want you, how do you walk across the room? Look at me go. Well, now I'm going backwards. Look at me. How did I move? Well, I sent a signal from my brain to my muscles, and I contracted muscular tension. So I'm going to try not to be very theoretical here and just get to how do we move faster, how do we accelerate, how do we move close to the speed of light or closer to the speed of light. I do have good ideas. But the word tension is the proper generality for any two systems in contact. A tension path models the direct contact of systems distributing temperature. Remember, temperature, the cosmological microwave background, that's our backdrop, that's our environment. Matter concentrates into energy, and well, we're going to be very clear here about what we mean in the different terms. Again, forget theory, Brad. Just solve something. But the difference between, or to demonstrate a tension path, right? If I smack my foot on the ground, my computer might vibrate a little bit. But it's because my foot's sending momentum through the floor sending momentum through the table it's on to the computer that it's over on my little nightstand thing. So the tension path is my foot, where it contacts the floor, where the floor contacts the nightstand, where the nightstand contacts the computer. The shortest path, right, my geodesic would be directly to the computer, but there's all of these molecules in the air disseminating or distributing the temperature. So that's what a tension path is. Now, what's the difference between momentum versus energy? Well, luckily we've developed a new math subject, so anything that ends in y, anything that ends with the sound E represented by y has to be more general. So momentum is always, well, now I walk across the room. Now I want to walk across the room faster. What am I going to do? If I do something and I want to do something faster, what am I going to do? I'm going to form a rhythm. And how do I form a rhythm? Well, I time my tension. Timing is everything. Woo, look at me. So rhythm times. But energy is the potential for movement. Momentum is the word. Momentum and rhythm are the used words for actual movement. And this is a distinct differentiation than actual theoretical physics right now today. I don't think, kind of a random tangent, but I don't think light has, it's not relevant. But, right, energy ends in Y. So momentum versus vibration. As proven empirically by every time people say the word vibration. But you can see this very easily for BattleBots. Plug the show BattleBots real quick. I think it's one of my best sport in the game. But you'll see this all the time. Empirically, anytime they say the word, they'll often say the word energy for movement, and it'll strike me as just like literally the wrong word. So go watch BattleBots. Great show. But momentum and rhythm are the words used for movement. Vibration and energy are the words used for the potential for movement. Someone comes downstairs and says, "Oh, I don't have a lot of energy today." Translate that. What does that mean? They don't have a lot of motivation. They don't think they can do something. They don't think they can move. That's literally what people are saying. So the next thing to develop a better engine would be to just definitively determine the state of computing. I don't know. I play computer games. I play games. I'm very intuitive at everything. Not exactly the state of art or whatever for computers. Are we definitively sure that solid state drives or liquid state drives are better? On a cosmological or engineering standpoint, maybe plasmas. Maybe some sort of dynamic of temperature. But we need to answer the question, what solid versus liquid, right? That's not direct to any given material. And then once we determine whether solids or liquids or some sort of mixture of the both makes sense, well, then we determine what materials do we use to build our spaceship. Well, again, the existence of the different shapes of spaceships right now definitively tells us there's not a unique geometry. There's not a one answer and this is the shape of something has to be. I also heavily suspect, like I said, they might, or I don't say they might, it might even be likely that they have different materials, but it strikes me as exceedingly unlikely that it would be unique, that the universe would be you wouldn't be able to generate some sort of technology in this section of the universe versus this section, right? Liquid versus solid. Any molecule or any atom can be in a liquid or a solid state. So I think I've introduced something called the preservation of dynamic. So what do our alien spaceships do? They move silently, they move quickly, and they're very agile. So the kind of idea is, like I said, material-wise, I just have to play around with stuff, not sure. Geometry, again, not sure if it's, again, I think you build some sort of dynamic and then you preserve that dynamic. Or like somehow we have some sort of like orb energy ball thing, or just, again, a mechanical piece. You accelerate it or you get it going. Like, alien spaceships are not completely silent. They do accelerate, they do give off sound. By the fact that we can register them on radar tells us they're not invisible to any sort of light spectrum in any way at any level of technological development. So we just have our mass and our light. But then we can start determining solid versus liquid, then we can start determining what materials to use, if there are better materials. Like I said, there's maybe different alloys, just don't know. But geometries of batteries and spaceships, I do not think it's unique. They will be equilateral, like they'll be in the shapes of the polygons. But the next question we need to ask is, can there be non-metal electric substances? Electricity is the flow of electrons. Every material has electrons. Every material has electrons. So can we have non-metals that are electric? I don't know. I really think this is interesting. We don't have the right definition of what electricity is. Like I said, signal preservation or signal regeneration. Brad Boas, create an engine right here in my room. It has some sort of self-sustaining dynamic, and then I start traveling, and I don't need to grab any materials from the environment. I don't need any power. I don't need any energy from the environment. The inefficiency of the engine that I've built is exceedingly negligible, so I can go fly around. Or a more interesting thing for me is if you can somehow signal preservation for either light or sound. Can you send a signal in the same way doctors can do surgeries robotically, or you can remotely control a computer? Maybe you have to send a beacon, or you have to send a robot to another planet, and then you can start, like, again, building the materials at a different place. So you only have to send the encoded light, and then you can reconstruct the actual physical system. And that wouldn't work. Teleportation does not exist for anything. Does not exist, physically wrong. Don't need to call an alien. That is axiomatically incorrect. But combustion and electricity, something strikes me about electricity of being way more general than we've applied it. Temperature, again, I'm literally trying to guess how to build a new engine in 10 minutes, don't know. But those are the questions we need to answer. Signal preservation versus signal regeneration, I would be pretty impressed with signal regeneration more so than signal preservation. Because the preservation of dynamic, to me, I've derived that's something. How do you materialize that as an engineer? How do you, again, build an engine? Not exactly sure. But like I said, the geometries will not be unique. And I heavily suspect materials will not be unique. Will there be better materials? Sure, right? Is it better to build, is steel stronger than bronze? Yes. Are they both metals that can build things? Yes. So again, intuitively, it strikes me as goofy and weird, and to think that like we're super special in a good or bad way from like building technology. I don't think the universe would ever have environmental conditions where civilization couldn't reach technological plateaus. And so, I said every species that can fly around can do something to this effect, and then once a society has it, this is the engine driver for all again, movement or storing, potential for movement or energy or momentum. It's a once and for all answer. and it will be used for all technology. But those are my thoughts there. So thanks for watching Evolution and Technology. And again, maybe if I had more than 30 minutes to try to guess how to build a fucking spaceship, I could just build this shit, honestly. But temperature, shape, that's the direct difference between momentum and energy, aka vibration. And yeah, thanks for watching part 14.